Wolff-Kishner reduction, you need to remember, first of all, this is related to the reduction of aldehyde and ketone, mainly aldehyde and ketone. Although in books it is written that a reduction of carbonyl group, okay, carbonyl group in aldehyde and ketone only. So first of all, aldehyde and ketones, when we get them reacted with hydrazine, then hydrazones are obtained or alkanes are obtained. Depending on what we are getting reacted with hydrazone and the condition. Okay, and the conditions. So by now you should be able to recall it. So suppose we just an example, I have an aldehyde, for example, CH3CHO, okay, and I get it reacted with the hydrazine, and I'll get, instead of writing CHO, write it like C, so that it becomes easier to understand. That CH3CH double bond C, sorry, NH to NNH. So this is hydrazone. This is hydrazine. Yeah. Now, if you get it reacted, how to get alkane? So both it is important for both, whether you are getting hydrazone or you are getting alkane, what you need to use. If it is followed by, and that makes the complete reaction, Wolff-Kishner reaction. If you want to get alkane, then from here you will get it reacted with KOH and glycol, you will get alkane. In this case, because you have two carbons, you will get ethane. Now, sometimes in this reaction, this step might be missing, hydrazone step. But this is important. Okay? This step is very important because sometimes it is asked, specifically in JEE, they are very fond of hydrazine and hydrazone. They will specifically ask which particular compound will be formed or hydrazone is formed by reacting that. So if you don't know this step, there will be a problem. So hydrazone will be formed from hydrazine. After that, if you want to get alkane, you will get it reacted with KOH and glycine. Next, Rosenbaum reaction. This one is very easy one and very popular one. Very easy and very popular. Again, a very popular reduction, but reduction of acid chlorides. Acid chlorides means acyl chlorides. Rosenbaum will be for RCOCl. And you know that what is RCO? This is acyl group. And this whole is known as acid chloride. So acyl chloride or the same thing is known as acetyl chloride. Same thing is known as acid chloride, means acid halide. Same thing is written like this. So for example, I just take in place of R, I take CH3. It will be CH3COCl. So Rosenbaum reaction is simple with hydrogen in presence of lead and BaSO4 to obtain aldehyde. Simple. So plus H2 in presence of palladium, I said lead, palladium, BaSO4, and there are two carbons, so it will be CH3, CH. Can be applied in aryl compounds also. Okay, so if you have aryl compounds, same thing. Acetaldehyde, benzaldehyde or benzyraldehyde, it's a ring, can be obtained. Aditya, last was this one, Wolf Krishna. Now, as I said, Wolf Kirchner is used for both. The complete reaction obviously is still alkane, but it is used for both for hydrazone or further to alkane. Now, in this one, very important question appears here. Aditya, I will be covering only 30. However, in total, there are 54 reactions. And if I cover all reactions of JE and NEET also, there are around 81 reactions, which fall under the head of named reaction. But there are 29 or 30, which actually cover most of these. And the rest one either are related to MSc, which have been incorporated MSc chemistry unnecessarily, okay, and they have not been asked in last 8 to 10 years. So I don't discuss those ones. Okay. Yes, Karthik, then I am coming to that. Okay. Now, very important question appears from here, that what is the function of barium sulfate and lead? So lead is catalyst. Sorry, palladium. Not lead. Palladium is catalyst. Palladium is catalyst, but it is very strong it has very strong activity, means increases the rate very high. Hence, BaSO4 acts as poison. So palladium is catalyst. Barium sulfate is not catalyst. It is used to reduce the activity. Otherwise, it will further get reduced to alcohol. You know that aldehydes can get reduced to alcohol. So what is the function of barium sulfate? It acts as poisonous, main function to prevent further reduction to alcoholic grade. That is the function of barium sulfate here. Now, if you see previous year questions of NEET and JEE, these questions have been asked in various ways. For example, objective type questions, if you see, you will see question of type that the function of palladium and barium sulfate is, then options will be palladium as poison, barium sulfate as catalyst, or palladium as promoter and barium sulfate as poison, like those. So the correct answer will be palladium catalyst and barium sulfate poison. Next, decarboxylation reaction. This is something you have done in 11th standard, that the salt of acids, say sodium acetate or sodium ethanoate, same thing, okay? When we get it reacted with soda lime. Now, soda lime is mixture of NaOH and CO, out of which NaOH reacts, CaO is catalyst. You get one carbon less hydrocarbon from this reaction. Karthik Dhanai, promoter actually increases the activity of catalyst. Promoter itself is not a catalyst. Next, Hall-Vollard-Zelinsky reaction, and this will actually appear as HVZ reaction. So you should know the complete name. Normally it appears as HVZ. So first of all, it is for aliphatic carboxylic acid. Okay. So when you get aliphatic carboxylic acid reacted with bromine, chlorine, not iodine or fluorine, okay, chlorine or bromine, okay, in presence of phosphorus, then you will get alpha halo acids. So first of all, it is only for aliphatic acids only. Then you get these reacted with either chlorine or bromine in presence of phosphorus. Now, in presence of phosphorus or halide, say PCl3, PCl5 will also work. But normally you will get reaction as chlorine or bromine with phosphorus. So combination will be chlorine or phosphorus, bromine, phosphorus, chlorine, PCl3, like this. Okay, all these combinations can appear. So from here you will get chloroacid. Okay, from here you will get chloroacid. So this is intermediate step, and which will further, you don't need to do anything, okay? Which will further, you'll get dichloroacid. So chlorination will be in steps. You can omit the intermediate, okay? Then from chloro, dichloro. Yes. And as I said, it will be alpha chloro. So why I am saying alpha chloro, I'll tell you when I explain the reaction. Chlorine will get attached to that carbon, which is alpha carbon, means which is attached to COOH group. And that is important. That is asked as question also. Okay. So take any acid, say I'll, I'll take propanoic acid, not acetic acid, because there will be only one carbon attached to COH group. So let's take propanoic acid and get it reacted with chlorine in presence of phosphorus. So this reaction will happen in two steps. Okay. So first CH3CH1 chlorine will get attached on alpha carbon. This is alpha carbon. This is beta carbon. So on alpha carbon, then again further chlorination will take place. But on alpha carbon only. So very important keyword related to HPZ reaction is alpha carbon. Okay, halogenation, rather say multi-halogenation. Multi-halogenation means there can be two only because valency is complete after two. In case of propanoic acid, not in case of acetic acid. In case of acetic acid, all three hydrogens will be replaced. In all other cases, there will be dichloro. Next, Gabriel Thalamide reaction. This is something you have to remember the structures, and that's where most of the students struggle if they don't revise. That's my warning. If you don't remember the structures, there will be problem. So thalamide structure you have to remember, and moreover, you need to remember this is one of the method for preparation of primary amine. Yes, Avnish, correct. Good. To primary amine. So as I said, you need to remember the structure. First, structure of thalamide. Okay. So first, right. So first, we will get from thalamide, we will get potassium thalamide. First, I'm writing just to make sure that you understand. Okay. So you have thalamide. From this, you will get potassium thalamide, and from that, this you will get an alkyl thalamide, and last step, aqueous NaOH, you will get primary amine. So this is something you need to remember. Cram it. Thalamide to potassium thalamide to N-alkyl thalamide to primary amine. Now, when I say primary amine, remember I'm talking about aliphatic because Although thalamide is aromatic, the amine produced is aliphatic. So here I need to be specific. And I'll explain why it does not happen. Why we don't get aromatic amines, even aromatic primary amines, we don't get. And first understand thalamide to potassium thalamide to and alkyl thalamide to primary amine. Now understand the structures and memorize these structures. Thalamide is one benzene ring, yeah, and then one structure that is actually the thalamide structure. First step is you get it reacted with an alkali, KOH, to get potassium thalamide. So first step was thalamide to potassium thalamide. Hydrogen is replaced by potassium. Now this is the main step. The next second step, which explains why aromatic primary amines are not produced here. Because here we get it reacted with which type of whatever amines we need to produce. For example, we need ethylamine. Okay? So we will get it reacted with C2H5 ion. So here this compound will decide which amine is to be produced. Okay? So now this alkyl group will replace this potassium. Reaction is very easy. You just need to remember the steps. NC2H5. So first hydrogen was replaced by potassium, then potassium replaced by alkyl group. So that's why we call it and here in this case ethyl thalamide. So it will depend on which alkyl group replaces potassium and ethyl thalamide and propyl thalamide like that. Last step is reaction with aqueous KOH or NaOH. And in last step, you get whatever alkyl group you had used there, that amine. So in this case, ethylamine. And rest. NaO will get attached to CO. So basically, this NaO and this N. Okay. CO was already there. This CO and CO were all. These two hydrogens, so say two NaOH, okay? These two hydrogens make here H2. This H2 comes from hydrogen. Next, Hoffman bromide reaction used in conversions also. So again, if we have an amide, okay, and remember amide is sometimes written as acid amide because it contains CO groups, okay, RCO group, acyl group. The acyl group is actually acidic, so that's why it is known as acid amide. So when it is reacted with bromine and sodium hydroxide, in few cases potassium hydroxide prefer sodium hydroxide. Okay, then primary amine is formed. Remember all these things. Tanishka and Avnish have given correct answer. Good. So first, what is Hoffman bromide reaction? You need to write that if you have amide, you get it reacted with bromine and NaOH, you get primary amine. Very important conversion method sometimes you will use to convert amide to amine. And it is applicable for both aliphatic as well as aromatic if we compare it with the Gabriel Thalamide reaction. Sorry, the Hell Volhard Zelinsky reaction. HBC. And this one also, because here, as I explained here, aliphatic amine is produced. But in Hoffman bromide reaction, you can get primary amine, both aliphatic as well as aromatic. Now, amide will be any something, say example, CH3, CO, NH2. Get the trick with I think it is 4, but I'll balance it. So, and this is degradation. Okay, it is Hoffman bromide degradation. That's why it is also called degradation. The reason is we get amine of one carbon less than the amide. So if there are two carbons here, the amine will have only one, CH3 and H2. That's why this is known as Hoffman bromide degradation. And you will have sodium carbonate, NaBr. We have used bromine, NaBr, and what? No, over here, some line number. NO2, it should be Na2CO3. 4 sodiums here. Back. Same reaction will be for aromatic. So if you have benzamide in this case, In first case, it was ethanamide. Okay. Ethanamide, or common name is acetamide, also known as, although rarely used, but you should know acetamide as well. Similar reaction here. Okay, Aryan, this is the previous one, Gabriel Thalamide. No, next one, ammonolysis. So first of all, when we say ammonolysis, what actually we are talking about? Whenever we are talking about ammonolysis, remember we are talking about ammonolysis of alkyl halide. Okay, ammonolysis of alkyl halide. Mainly it will be alkyl halide. Okay, unless it is mentioned. If it is just ammonolysis, alkyl halide. So one new, this is the previous one. Done, upon you. So in this case, ammonolysis will be with alkyl halides. At the same time, ammonolysis can be done by ammonia or ammonia derivative, means amines. So ammonolysis of alkyl halide can be done by ammonia or ammonia derivatives in presence of alcohol. Okay, in presence of alcohol. So write it something like that. Alkyl halide plus the microphone arrow, ammonia or its derivatives. Okay. Depending on whether you are using ammonia or ammonia derivatives, you will get amines. Which type of amines we will see. Okay. Depending on whether you are using ammonia derivative with ammonia, obviously you will get primary amine. But with derivatives, you will get secondary amine, tertiary amine. Or if you already use tertiary amine here in this case, then you might get uh, the salt also, ammonium salt, quaternary ammonium salt. I'll show you. Now, where is the usage of this one? The usage is that if you need to convert primary amine to secondary amine or secondary amine to tertiary amine, this is very popular method. Or just to produce amine from alkyl halides. So all applications are there, alkyl halide to amines. But because you are using amine already here in this reaction, okay, remember that it is not just production of amine, okay, from non-amines. It is production of amine from amines or ammonia. So first example I'll take with ammonia, and then I'll consider with ammonia derivative. So say you have Br or Cl chlorine, you can take and get it treated with ammonia. First reaction I'm in presence of alcohol. When you heat it, you will get amine. So remember here, it was just ammonia, you got primary amine. Ethyl amine. Bundle. Here it was just ammonia. But if you use primary amine, you will get secondary amine. If you use secondary amine, you will get tertiary amine. If you use tertiary amine, you will get quaternary ammonium salt. So suppose now you have, instead of ammonia, you use primary amine. You use this one. Okay? And actually this reaction, that's why propagates. Okay? That is the reason this reaction propagates. CH3, CH2 does not stop here. Okay? Plus CH3, CH2, NH2. Okay? Ethylamine we are now using. So again, alcohol is anyway already there. We are heating it. Now CH3, CH2, all twice N. Need to write HBr, but if you want, yeah. So what is the trick? The trick is remove HBr. One H gone from here, Br gone from here. Rest will get attached. CH3, CH2, NH, CH2, CH3. It means two CH3, CH2 are attached. So that's why I have written this one. It will be actually like this one, CH3, CH2, NH, CH2, CH3. Once you attach alkyl group to NH, it will look like this. I have written it like this because this is the way to write 2-degree amine. Now this is, if you remember the nomenclature, N-ethyl amine, because one ethyl is attached to nitrogen. If you consider one as, so just explaining, if you don't remember, CH3, CH2, NH, CH2, CH3. So instead of writing NH, I am writing NH. So if this is the main chain, this ethyl group is attached to nitrogen. Okay, so that's why it is written N-ethyl. After that, this is ethylamine, N-ethyl amine. N is written to indicate that ethyl group is not attached to carbon, rather attached to nitrogen. So N is shown here to indicate that ethyl group is attached to nitrogen. Now this is 2-degree. Rule is very simple. Here also, suppose in first reaction, this one, if I write it as HNH2, so this HBr will go away, and CH3, CH2, NH2 you will get. Okay, so this is the key to write ammonolysis reaction. I will be erasing this one. Just note down quickly, as I'll explain for secondary amine and tertiary amine as well. Shiv, in that case, that will get attached. The mechanism will remain same. Whatever I have done, for example, I have removed HBr and rest got attached. It will be same thing. Suppose in place of this one, you take CH3, CH2, CH2, NH2. So in this case, this group will get attached here. Clear? Now suppose you take this secondary group, because this will also react. This will also the second. I'm considering same ethyl bromide. Nothing. So instead of erasing, let me CH3, CH2, Br. This we already had. And CH3, CH2 whole twice, NH was produced. I'm writing it differently so that I am writing NH here and CH3, CH2 or CH2, sorry, CH3 whole twice here. So this HBr will go away and alcohol and heat, CH3, CH2 whole thrice. Okay, now this group and these two group already there. So three groups attached to nitrogen. So here it is tertiary, and how we will name. Now there are two ethyl groups attached to nitrogen. So I will write N diethyl amine, not amine, ethanamine. N diethyl, there will be two ethane. Now this is 3 degree. So from 2 degree amine, 3 degree amine operator. Remember, we are talking about ammonolysis. Now this 3 degree amine will again react. So CH3, CH2, Br plus. Now in this case, there is no hydrogen. Okay, there is no hydrogen, so no HBr will be produced. In this case, it is CH3, CH2 whole thrice N. There is no hydrogen with attached with this nitrogen. So HBr will not be formed. Rather, these will combine and will form salt. Conditions will be same, C2H5OH heat, but it will be CH3, CH2 whole 4 and Br. Now, because it is salt, make sure that you show the charge. So the name for this one is, you can write down. There are 4 ethyl groups, so we will write tetraethyl, and it is actually ammonium salt. Okay, ammonium bromide. 4 degree ammonium salt. This is not amine, this is ammonium salt. That's why also written as quaternary. Similar to as we say secondary, tertiary. Okay? Similarly, quaternary ammonium salt. Primary, secondary, tertiary, quaternary. Ah, yes, Karthik Tyagi, you are correct. That's why it is ionic compound. Next, acetylation. When we are talking about acetylation, okay, then it is actually removal of, not removal, rather displacement, no, replacement, rather, a substitution of hydrogen atom from the alcoholic group or from maybe amino groups also, phenolic group also. I'll show you the reactions, then it will be clear. Okay, 1 or 2 degree, not tertiary, by an acetyl group. Okay, the acetyl group, you know, I have told you acyl group, RCO, 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 remember. Okay, so if RCO means acetyl halide, RCOCl, okay, basically replaces the hydrogen. Hydrogen from what? From OH group, okay, or from amines, only primary and secondary amines, or phenolic group also. OH means when I am saying OH group, including, you know, the phenolic group that is on benzene. So the reaction will look like something. First, I'm taking the simplest one. RCOCl, here are, you take CH3 CuCl, and it will replace this hydrogen. This hydrogen. Okay? This hydrogen will be replaced by acyl group CO, CS3. Okay? This Cl and this H will combine and will form HCl. So this will be ethyl acetate. Make sure that you are writing all these reactions and revise today only. If you have too much work today, make sure tomorrow morning, not tomorrow evening. So OH group of whether it is aliphatic, and as I said, of phenolic group also. Okay? So even if it is like this will replace the hydrogen. And will produce CH or CO. O was already there, hydrogen will be replaced by COCH3. Phenyl acetate. Okay, so alcoholic group, including phenolic group, when reacted with acyl chloride or acetyl chloride or halide, acetates are produced. Or as I said, primary amine and secondary amine also. So this reaction will happen with amines also. Suppose instead of alcoholic group, I have primary amine. I'll go for secondary amine as well, but does not happen for tertiary amine. Plus CH3CO, Cl. In this case, H will be replaced. One H will be replaced from here. Okay, so NH will be as it is. That other H will be replaced by CO, acyl group. And you know it is N-ethylethanamine. In previous case, we have seen. Now for the second one, say secondary. So for secondary, say it is CH3, CH2 whole twice N. And with the same, we get affected. So here in this case, it will be, this hydrogen will be replaced. So write it as it is CH3, CH2 whole twice N. Remaining hydrogen will be replaced by CO and sorry, CO, CH3. And it is NN diethyl ethanamide. So write it yourself. NN diethyl ethanamide. What do you mean by that, Shiv? Only by secondary? It happens for primary also. No, not possible for 3 degree because there is no hydrogen. The reason is there is no hydrogen. It has to replace hydrogen. And tertiary amine doesn't have any hydrogen attached to nitrogen. The acetylation very important from board perspective. Next, benzoylation. Again related to amines. Okay. And again primary and secondary amine. So amine reacts with benzoyl chloride. I'm just writing the reaction so that you can understand and then I'll explain. This is primary amine. Okay, I'll show you the reaction for secondary amine as well. And benzoyl chloride, C6H5, COCl. So this is benzoyl group similar to CH3COCl. This is SI group. This is benzoyl group. Benzoyl chloride. In presence of alkali, you can say, NaOH, for example. In few cases, it is written as OH minus also, just to show that there is alkali percent. Then we have CH3, CH2, and H, CO, C6H. So this This is CO I have written as OC. This actually gets attached. Hydrogen is replaced. So it's a similar reaction. What we did here, acetylation, similar reaction. When it is done with benzoyl chloride, it is called benzoylation. Benzoyl group gets attached, replaces hydrogen. Again, as I said, it is primary and secondary amines only. Why I said? Because tertiary amine doesn't have any hydrogen to be replaced. So for example, CH3, CH2, whole twice, NH, secondary amine. Just see the difference, okay? One difference, what I'm explaining here in this particular case. In here, I didn't say that the presence of NaOH is necessary in acetylation, okay? But here I am specifically writing NaOH. So it will take place in presence of NaOH or any most of the alkalis. You can mention OH minus also. So in this case, it will be CH3, CH2 whole twice N, and then this hydrogen will be replaced by CO C6H5. Similarly, here you can have aryl group also. For example, C6H5, primary amine, if you take it, will be NH2. Okay. And here you can have C6H5 COCl. So both are aryl in this case. Okay. So C6H5 NH and then COC6H5. Why don't you write it OC? Last one. It will be N-phenyl benzamide. This is benzamide group. And this phenyl is attached on nitrogen. So that's why N-phenyl benzamide. Okay. Similarly, this one, if you name, this one will be N and diethyl benzamide. This will be just N ethyl benzamide. Ethyl attached to N, this is benzamide. No, Mansha, it won't be wrong if you write COC6H5. It won't be wrong, but this is the convention because this end of oxygen actually gets attached to nitrogen. So that's why the convention is that if you write it like this, you write it OCC6H5 or you write C6H5CO NH CH2CH3. Then again, it is attached with oxygen. If you write it on left hand side, means oxygen has to be close to nitrogen. Simple. Whether you write from left hand side or right hand side. But if you write CO instead of OC, that is not wrong. That is right. Now suppose you have here also, let me explain again. Here also you have secondary, and you get it reacted with C6. On. Let's use here. Then C6H5 whole twice N, and the hydrogen after this will get replaced by OC6H5. So it means two phenyl groups are attached to nitrogen. So you will write N diphenyl benzamide. N diphenyl benzamide. With nitrogen, Ansha. Hydrogen can have only one bond. How can hydrogen have double bond, two bonds? Okay, so benzoylation is similar to acetylation. The difference is that you use NaOH. Otherwise, it is same, but with aromatic compound. Next, carbylamine reaction. The very, very important reaction which appears almost every year in different sets. Okay, but it appears. So again, reaction of primary amine with alcoholic potassium hydroxide mainly. You can use sodium hydroxide as well, but we use normally potassium hydroxide, QH, alcoholic QH, and chloroform. Isocyanates are formed. A very bad smell is an indication of this reaction. Okay? If we get a very bad smell, this is an indication of that reaction has happened. Primary amines, you can take CH3, CH2, NH2, our favorite one, reacting with alcoholic gas. Remember, this is alcoholic, okay? So alcoholic, that will give you isocyanate, NC. So CH3, CH2, N. Up to here, it is like this. And it is actually triple bond C, in which one is coordinate bond. Remember, one is coordinate bond. Nitrogen has total 5 valence electrons. So 2 actually it donates. You can write just NC, isocyanate, plus 3 KCl and I guess 3H2. So this is ethyl isocyanide. Ethyl isocyanide. Very bad smell, or in civilized words, unpleasant. happens both for aliphatic as well as the primary aliphatic and aromatic amines. So if it is aromatic even, then the reaction will take place. In that case, it will be on a benzene ring that NC will be formed. Otherwise, the reaction is same. CHCl3 plus alcoholic QH will give you NC vinyl isocyanide plus 3KCl. If you want, you can show it like this. One coordinate bond, three bonds between nitrogen and carbon, one coordinate out of three. Yes, Tanishka, follow step. No pun, you correct. Tanishka, correct. Good. Next, mustard oil reaction. Not very frequently asked, but it is important because it has been asked in, I think, 2012, then 2015, then 2017. Chances of this one appearing this year. So again, similar conditions are similar to previous one. You need to have primary amines, whether aliphatic or aromatic. Okay. Again, there also we had alcoholic QH, but here we will have alcoholic carbon disulfide. Okay. And then we will heat it with mercuric chloride, not mercurous chloride, HgCl2. So try to understand the type of reaction. So primary aliphatic and aromatic amines. So our favorite one, CH3CH2 and primary. Then we get it first, we get it reacted with carbon disulfide. From carbon disulfide, we get something, okay, intermediate, which when we get reacted with mercuric chloride, after that, we get now the SCN group is actually ambidentate, if you remember. It can get attached from sulfur or nitrogen. In this case, it gets attached through nitrogen. So you will get here S, rather write something S P S. That gives better idea how it is. Okay. So this SC remains like this. This double bond becomes single bond, and with this sulfur, one hydrogen gets attached. Okay. And the other bond of the carbon is get NH CH2 CH3. So this way you will remember it. One sulfur attaches with hydrogen, single bond, other bond of carbon, the amine group gets attached there. Amine gets attached there. After that, we get it reacted with mercuric chloride, HgCl. And we get isothiocyanate because it gets attached through nitrogen. That's why iso. I'll just First I'll write and then I'll explain why we are calling it iso. So here I'll get CH3, CH2, NC. CH3, CH2, NCS. Rather, other whether you write it or not, mercuric sulfide and HCl. These two hydrogens, this hydrogen and this hydrogen, these will combine with chlorine. So it will be 2HCl. Remaining Hg will combine with sulfur, HCl. So here ethyl isothiocyanate will be. If it would have been like this, CH3, CH2, SCN, then it would have been ethyl thiocyanate. But because it is attached with nitrogen here, so similar to CN and NC, so if it is attached from nitrogen, it is iso. Yes, Abneesh, because it is ambidentate. But in this case, isothiocyanate is produced. Mustard oil reaction, this is known as. Basically, it is the reason there is nothing like mustard oil. It is just because there is a smell of mustard oil in this one. That's why. When this reaction happens, the smell is like mustard oil. So that's why mustard oil, not mustard oil, is produced. Next, diazotization. Diazotization is simple reaction that you have primary aromatic amines and you get it reacted with nitrous acid, which is produced in C2. That is NaNO2 and HCl. And a diazo group is introduced. So this is very simple, but I am writing that it is effectively only for 1 degree aromatic. Okay. So logically, it is aromatic amine reacted with HNO2, nitrous acid. But this nitrous acid is produced by reacting NaNO2 and HCl. So it is not written like this. However, the reaction can appear like this. Okay. So first I am writing it like this. HNO2 or HONO. I am writing it like HONO just because it is the convention. I'll tell you why. And then we have dilute HCl. These conditions you have to remember. Okay. And I have already told you that diazo group are very unstable. So the temperature has to be very low, 0 to 5 degrees Celsius. That is 273 K to 278 K. So it will introduce the group. Now, the same reaction can appear like this also. Here, it can be written as NaNO2 plus dilute. Okay, nothing else. Same reaction. The reason is because this will produce HNO2. Now, why I have written here as HONO, the reason is if you compare it with the reaction of aliphatic amine with HNO2, this is not diazotization, what I am going to discuss, okay? I'm just comparing it. So in that case, suppose it is CH3CH2NH2, primary amine, and we get it reacted to same reaction, okay? Either you write NaNO2 plus dilute HCl or you just write HONO. So instead of writing HNO2, I am writing HONO because in that case, if you remember, alcohol was produced. So this OH actually replaced this NH2. This N and N combined to form N2, H2 and O combined to form H2. So primary amine, if it is aliphatic, it produces alcohol. Then it is not diazotization. But you need to remember in conjunction. You need to remember both directions. And then you will be able to recall easily. If it is primary aromatic amine, it will be diazotization. If it is primary aliphatic amine, it will be formation of alcohol, primary, and nitrogen gas will be evolved. Here also, the reaction can be written as similar to the other one. HNO2 is produced in C2. So this is the term to write that it is produced at that time, at the time of reaction. We don't use it. We don't use it that it is already prepared. Rather, it is prepared in the reaction. Okay, next Sandware reaction. It's very easy, right? That from the diazonium salt you produce uh, halogen compounds. So, for example, you have N2Cl and you heat. Instead of CuCl, you can write Cu2Cl2, which is a rather correct way to represent it. That is how it exists. It does not exist as CuCl, rather it exists as Cu2Cl2. Chlorine will get introduced, nitrogen and HCl gases will get evolved. Both will be gases. So if you show the bonds, then here you can show the bonds also if you want. Okay, you can write it like N triple bond NCl minus. In this case, you will show it as bonded N atoms. And this is a better way to represent it because when we write it like this, mm, N2 plus Cl minus, it gives us a wrong hint that N2 has plus charge. However, it is only nitrogen, one nitrogen which has plus charge, formal charges if you remember. Okay. No physical significance, just for explanation purpose. And this is NCl part, separate from that. Next, coupling reaction. Very important reaction, and it is called coupling reaction because it forms a link, couple. Okay, that's why it is called coupling reaction. Again, of diazoxide salt, although might not appear diazo group reactions, but important anyway from JE perspective. So, aryl diazonium salts reaction with phenol, both groups will get attached through nitrogen bonding. That is known as coupling. And these products formed are used as dye. Okay, just explaining, you know that we have diazo group and we get it reacted with the phenol in presence of any alkali, NaH. Then this HCl, this HCl, okay, not HCl, rather OH will get attached. I'm writing it slightly differently because I will be able to explain through coupling, because coupling will happen from here. So just erasing, okay? Different way. The same thing, but I'll rotate the molecules, then it will be easier. Yes. Okay, this way it is easy to, and this is OH. So coupling takes place, this hydrogen actually here, it gets out, and rest is joined. Now, because plus sign will disappear, it will be double bond. And OH was already there. Minus complete and NOH. Yes. Whether you write this HCl or not hardly matters, but you should know that HCl is produced and that's how the coupling takes place. So that's why coupling reaction. Okay. Now it is, this hydroxyl group is at para position as compared to this one. So the name of this one is para hydroxy azo group benzene. This para hydroxy azo benzene. In total, this became para hydroxy azo. Okay, and then benzene. Yes, this is orange dye. Correct, Karthik and I. The reason, okay, your question is, Vijayant, why it is double bond? The reason is that you have to balance the valencies. Okay. Now, how you balance the valencies when this hydrogen, okay, remember this combines with this nitrogen and chlorine goes away and combines with hydrogen. Now remember, chlorine minus cannot combine with hydrogen because otherwise HCl will carry a negative charge. Okay, HCl will carry a negative charge. So what will happen that this chlorine will take away the electron with itself. So it will go as Cl minus. When it will go with Cl minus, this positive charge, okay, and it will become H plus. Okay, this will leave as H plus. It means there are two electrons now available here. When it leaves as H plus, there are two electrons. Those two electrons are now provided to this nitrogen by this end, by this end. So now this nitrogen has not provided any electrons to the nitrogen. So this positive charge will appear and this bond will disappear. It is about balancing the valencies. The overall molecule has to be charge neutral. But you don't need to go into those details because you won't get any extra mark for that. Now, similarly, if you have written this one, okay, if the same thing I get it reacted with aromatic amine, then again dye is formed. So if it instead of alcohol, I use primary amine, aromatic, okay, primary aromatic amine. So just note down if you want. I will be raising this one. However, you can write down this one with the help of next one also. Suppose I have, I draw the same way. Okay, you have a diazonium salt, and now you get it reacted with primary aromatic amine. Instead of OH, now you have NH. And you know there is H here, so this HCl will go away. And similar to that previous one. Okay. The only difference is here. In that case, if you remember, I had written NaOH, means that happens in basic environment. That happens in basic environment. Previous one, when I used phenol, and that is the difference you need to remember. Say it to yourself again and again. When we are talking about coupling reaction, if it is with phenol, we will use alkali, NaOH, that is OH minus. But if it is primary aromatic amine, we will use acidic environment. So in previous case with phenol, it was NaOH or OH minus. With amine, it is acidic environment. Reaction is similar. So instead of OH, now there will be NH2. But coupling anyway is formed. So that's why coupling reaction. This is again a dye. But here at para position, you have amino group. So name will be para amino azobenzene. This is again a dye. Similar to para hydroxyazobenzene. This is also a dye. Coupling reaction, remember, we are talking about azo. Okay? Azo group is there.